Bismillahirrahmanirrahim. Dear students of English version 11, Assalamu alaikum. Now we will discuss on a very important topics of from physics first paper and chapter 4 Newton and mechanics chapter. The topics is related to moment of inertia and radius of gyration. You know the definition and equation of moment of inertia and radius of gyration. Now we will find out the moment of inertia and radius of gyration of a thin uniform thin rod about two axes. First of all, the determination of moment of inertia and radius of gyration about an axis passing through an edge of the rod and perpendicular on the length of that rod. First of all, we will find out the moment of inertia for a smallest division of that rod. Then with the help of integration we will find out the moment of inertia for the full length of the rod. Suppose the mass of the thin rod is mkg and the total length of the rod is here L, capital L. So from this information we can easily find out the mass of per unit length of this thin rod. So as first of all we will find out the radius of gyration and moment of inertia about an axis we have passed through on edge of the rod and perpendicular on the length of the rod here. So now let us start. So first of all, as we will find out the moment of inertia for a smallest division or smallest length of that rod, so we will have to know the mass of the particles of the rod for per unit length. Here we have taken the total mass is here mkg and length is L meter. So from here we can find out the mass of per unit length of the mass of the particle of the rod of per unit length. So let us write the mass of per unit length equal to m divided by L here, as the mass of L length is mkg, then mass of 1 meter length will be m by L here. Now from this information we can easily find out the mass of the particles of the rod for a smallest length dx. Suppose we have taken here a smallest length or ring on the thin rod and the length is dx. So now we will find out what will be the mass of the particles of the rod of dx length. As the mass of per unit length is m by L, so what will be the mass of dx length here? So the mass of the particles, the mass of dx length will be as it's a very smallest mass, let us take this dm into dx. So the mass of per unit length of this rod is here m by L. So the mass of the particle of the rod of dx length will be m by L into dx. Now we will find out the moment of inertia of that smallest of the particles of the smallest division dx. Suppose the particles of smallest division dx are remaining x meter distance from the axis. So then we can find out the moment of inertia of the particles of mass dm here. So now moment of inertia of dx length will be, here suppose di equal to dm into x square. According to the equation of moment of inertia, we can write this. Again, let us put the value of dm here. The value of dm here, m divided by l into x square into dx. So this is the moment of inertia for the smallest, the particles of the rod for the smallest length of dx. So now if we want to find out the moment of inertia for the total length or full length, then we will have to integral. So now the total moment of inertia I will be integration of di, and here our range is from 0 to L. For full length 0 to L, we will have to integral within this limit. So let us put the value of di here, m by L x square into dx. So let us integrate this again, m divided L 0 to L x square dx. Again m divided by L x to the power 3 by 3, and this is 0 to L. So again, now let us submit the upper limit and lower limit here. So moment of inertia I equal to m divided by 3L and L cube, x cube, here x cube, and the lower limit is 0, upper limit L. Then let us put the value m divided by 3L and here L cube minus 0. So from here we can write the equation 1 by 3 m L square. So this is the equation to find out the moment of inertia of a uniform thin rod about an axis passing through on edge of the rod and perpendicular on the length of the rod is the equation of moment of inertia. Now from the again we can find out the radius of gyration. Now suppose the radius of gyration here, we know that the radius of gyration is identified as k. So if radius of gyration is k, then we can write here again I equal to m k square. Now putting the value at equation 1, now from equation 1 m k square equal to 1 by 3 m L square, mm cross, or k equal to, we can easily write L divided by root 3. So is the equation of radius of gyration of this thin iron rod So now the beginning information is same. Again, when we will find out the moment of inertia and radius of gyration of that uniform thin rod about an axis which passes through the middle of the iron rod and perpendicular on the length, the beginning equation will be same. So only the difference will be the limit here. So for this figure 2, now let us find out the moment of inertia and radius of gyration. From our previous information, the moment of inertia in this case also, first of all we will find out the moment of inertia for a smallest division of the iron rod. Suppose the length is dx, and from the axis the distance of the particles of dx length is here x, and the total mass of the rod is same m, and the total length of the rod is here L. So from the previous equation, the moment of inertia for smallest length of dx will be here di equal to m divided by L x square into dx. Suppose equation 1 is here. Now to find out the moment of inertia for the full length L, we will have to integral this equation 1 with the limit of from minus L minus half L to plus half L, as the axis divided the rod into two parts. So here the lower limit will be minus half L and upper limit will be plus half L. So now the moment of inertia, final upward moment of inertia for the full iron rod about this axis, I will be integral di, and the value of the limit from minus half to plus half, minus half L to plus half L, and the value of di, let us put again the same way, m by L x square into dx. So now m divided by L integral minus half L to plus half L x square dx, and let us put the value. Let us complete the integration. M L again x cube by 3, lower limit is minus half L to plus half L. Again m divided by 3L, it will be x cube and limit minus L by 2 for minus L by 2 and upper limit L by 2. And let us put the value here, m divided by 3L, and here L cube divided by 8 and minus plus L cube divided by 8 here. Okay, now again m by 3L, here 2 L cube divided 8. So again you can write, so we can cross the 2 and 8 is there 4, so it will be 1 by 12 and ml square. So let us again check. 2 and 8 is close, 4. So will be ml cube divide 3 and multiply product 4 is 3 and 4, 12. So 1 by 12 ml square is the equation of moment of inertia about the axis when the axis will pass through the middle of the thin rod. And again, from this information, suppose is equation 2, and again we will find out radius of gyration. If the radius of gyration is k, then again we can write, if the radius of gyration is k, we can write I equal to m k square. Now from equation 2, let us put the value from equation 2 here. M k square equal to 1 by 12 ml square, 1 divided by 12 m l square. M cross here, so the value of k will be here L by 2 root 3. So it is the equation of radius of gyration. So dear students, these two information are too much important for both your SSC level, SSC exam and admission. So you will must remember these 4 equations. 2 is for the moment of inertia and 2 are for the radius of gyration. The moment of inertia of a thin rod about an axis which is passing through on edge and the perpendicular on the length of the rod, and another is about the axis which passes through the middle of the thin rod. These 4 equations are too much important, so you must memorize and you must remember these 2 equations for both your SSC exam and all admission exams. Thank you very much. Allah Hafiz.